my college, my dream, my life.
안녕하세요, 여러분. 마이 칼리지 컨설팅의 미리입니다. 자, 저희가 오늘은 새로운 컨설턴트 분을 데려왔어요. 이제 저희 회사에서 같이 일하시는 아이제이아 컨설턴트 분이신데요. 같이 이렇게 유익하게 정보도 듣고 그리고 소개도 듣고 이런 유익한 시간을 보낼 건데 전체적으로 영상은 영어로 진행이 될 예정입니다. 그래서 자막은 이렇게 밑에 저희가 달아드릴게요. 그 점 양해해 주시고 저희가 이제 진행을 해보도록 하겠습니다. So Isaiah, would you mind introducing?
Yeah, so my name is Isaiah Yim, and I am currently a PhD student at Yale University studying biomedical engineering. And I got my bachelor's degree in chemistry at the University of Michigan. So that's where I went for college. And right now I'm at Yale for my graduate degree. I've been working with high school students for quite a while now. You know, as a college student years ago, and even now, I work with high school students through MYCC, and I've done private consulting in the past with individual families as well.
Awesome. Thanks for the introduction. Today's video will be about the chemistry and the biomedical engineering exploration. So would you explain more about what is a chemistry degree?
So chemistry degree, I just want to make a distinction between chemistry and chemical engineering, because that's a huge difference. I was just a plain chemistry major, and my fellow colleagues in chemical engineering were more applications based. Plain chemistry is a little more theoretical. So you would do things like quantum mechanics, thermodynamics, look at the micro nano scale, while chemical engineers would come up with cool materials using chemistry, like different types of paints or different coatings for glass, things like that. With a chemistry degree, you can go into all types of fields. And even within college, you start off as a chemistry major. As you become a junior and a senior, and even during your research, you kind of branch off into different types of subclasses, subcategories. There's organic chemistry, organic synthesis, there's analytical chemistry. It depends on the type of, career you want to pursue if you want to stay within chemistry. But yeah, people specialize in different chemical fields. People have heard of biochemistry. Biochemistry is similar in that you only work with chemical compounds in the body. And that's a little more towards life sciences. I wouldn't really consider that as chemistry, because there's organic chemistry that's used outside of the body, and it's just a whole different category as well. Yeah.
Thank you. That's a really good explanation. Then did you specialize in any of the portion of the chemistry in college?
Well, I personally enjoyed bio-inorganic chemistry, which is still, a big field, but it's a subset of biochemistry, right? It's in the body. So we covered things like metals in the body, minerals and metals. I really enjoyed that because no one really thinks of metals in bodies, except that time I watched in X-Men where Magneto takes, iron out of a person. That's a little exaggerated, but that really got me thinking about the metals in the body. But on top of that, I did medicinal chemistry, which covers natural products discovery, natural products chemistry. And so I would consider myself in the field of medicinal chemistry and analytical chemistry.
Gotcha. So it's interesting how you pursued PhD in the biomedical engineering though. So how did the transition happen?
Yeah, so it was a huge transition. Once I graduated college, I took several gap years. And I would encourage students to take gap years because it really gives you a time to think and mature for yourself, and it's a good investment of time for your future self. And so I was always on a very straight path towards medicine. I wanted to go to medical school. Once I gave myself some time to think, I actually took 4.5 years, but granted that I always did something during those gap years. And so my first year, I even went to China, a very independent medical internship where I fundraised my own money to go there, made my connections in China. I don't even speak the language very well, but I did that for 9 months. And then I went to the National Cancer Institute to do research. And that's kind of where I shifted towards biomedical research. After I did a year there, I did 2.5 years of biomedical research at Cornell Medical College. And that's where I really refined my research skills, the way I think, the way I do things. So both a mental and technical maturing process during those last 2.5 years. I had that calling for research and shifted towards biomedical engineering.
That's a really good point. So we direct a lot of our students to research as well, because like the gap year and the research is all about really exploring yourself and what you really want. So unless you really take those routes, you really don't know what you truly want. So thank you for that, Isaiah. Yep. What kind of people would thrive in these kind of majors?
I realized that there are certain types of people who thrive in these environments, and they are detail-oriented, very persistent. They don't give up after one failed experiment. Because in research and in science, there are lots of failures. All throughout history, people made failures, and the outcome of all their failures are success, and we benefit from their successes. People who have those types of motivations will thrive. It's not a glorious, major. You're going to be spending time with your computer and not really socializing much. In the end, throughout your academic career, you're going to really mature as a problem solver. And we need problem solvers in the world. For those of you who want to be problem solvers, I think any type of science is great. Yeah.
Gotcha. Then what are the potential careers or jobs or future paths that students can take with these majors?
You can be anything you want, especially if you're gonna engage in a very scientific, technical major. You can become a researcher, you can become a developer in like big pharma, or you can even do things like law. Here at Yale, school has a really strong law school. I learned that some law firms will hire PhDs in sciences, and they will teach those scientists how to become lawyers. Patent law is kind of what I'm interested in. These companies like Apple or Pfizer, they will need experts to read into their technologies and then protect it using the legal system. Yeah, you can become a lawyer as a science major. And obviously you can become a doctor. The good communicators become like those Dr. Fauci's of the world, where he can literally take a very complex idea and even teach elementary schoolers what this whole pandemic is about. Even consulting. You become a consultant for big companies because they want that problem solving, help. So, those are some of the careers that I could think of, but there are tons and tons of careers that you can go into. There's always going to be something that you can do with your science, chemistry, biomedical engineering degree.
All right. Thank you so much for all the valuable information today about the chemistry and the biomedical engineering degrees. So I hope that this video really helped the students who's watching, because a lot of the students probably won't really know much about each of the degrees. So hopefully the video and the information that you shared is really helpful. So we'll continue to our next video soon. So thank you so much, Isaiah, for your time. All right, see you in the next video.